Alright, so here's the problem. You're trying to find a molecular formula from an element composition. You have the percents of carbon and hydrogen in your compound, and you have the true molar mass of the compound. Okay, the first thing you've got to do is figure out what the empirical formula is. The second thing you're going to do is figure out a multiplier that you can apply to the empirical formula to get the molecular formula. So first things first, let's get the empirical formula. To do that, you're going to make a little table. I'm going to put grams of element in the first column of the table. And I can take these percentages as though they are gram amounts. That works because if I had 100 grams of compound, this is how many grams of carbon I'd have and how many grams of hydrogen I'd have. So that's the first column in my table. The top row corresponds to carbon. The next row is hydrogen. Okay, the next thing I'm going to do is calculate moles of element. Why? Because the subscripts in the empirical formula are going to be mole ratios. So if I turn these gram amounts into moles, I can work with the moles then. So, okay, what do I have to do? I have to use the molar mass as a conversion factor, and I'm going to use the full molar mass, not some rounded off molar mass. So I'm going to take 92.26 divided by 12. Let's do it. And I get 7.68148. Let me just write that in. Now I'm going to keep a lot of digits in this because these are intermediate results, so don't round anything off or things get messed up in the end. Alright, so now I'm going to do the same thing here. This is going to be, the molar mass of this is like this. Okay, so if I take 7.74 divided by that, I get 7.6790 something. Let me write that in. Alright, the next step I do is find the simplest mole ratio. These will be the, if things work out right, these will be the subscripts in my empirical formula. Alright, how do I find that? The easiest way to do it is look at your numbers in your mole column here. Pick out the smallest one, that'll be this one, and divide everything in that column by the smallest one. Now I can see right away that if I divide this by this, I'm going to get something really close to 1. I'm going to just say it's 1. And I know this is going to come out to be either an integer or a simple fraction. So it's okay if I do that. And if I divide this by itself, I'm going to get 1. So what that means is my empirical formula is C1H1. Of course, we don't write in the ones. If there's no subscript, that means that there's a 1 there, understood. Okay, so there's my empirical formula. Now the next thing I'm going to do after I have the empirical formula is get the molecular formula, and I'm going to use the molar mass for that. The molecular formula is going to be some multiple of this. So I have to find some kind of multiplier that I can apply to this. The multiplier is the true molar mass, I'm going to just say mm for short, divided by the empirical molar mass, And now if I remember that upside down, the multiplier is going to have to come out to be an integer. This will always be an integer if I have it set up right. If I get it upside down, I'll get something that's, a fraction, not an integer. So let's put in the numbers and figure out what the multiplier is. 65.1 over, let me see, what's this going to be? It's going to be carbon is 12 and hydrogen is 1, so it's going to be about 13. Here, let's do it right. It's going to be 12.0107 for the carbon plus 1.00794 for the hydrogen. It's going to be 13.01864 or whatever. So let's do the math. 65.1 divided by 13.01864 is going to be, look, that's pretty close to 5.000. 5 is the multiplier. That means I'm going to take the empirical formula and apply this multiplier to each of the subscripts. So the molecular formula is C5H5, because that's 5 times those.